Okay, today we're going to talk about linear equations. That's equations that have at least one unknown. If it has one variable, it's written as ax plus b equals 0. And if it has two variables, it's written as ax plus by equals 0. To tell if something is a solution, what you do is you plug it in. So I'm going to take 5, and I'm going to plug it in here, and see if it's a solution. So 3 times 5 minus 1 is equal to negative 2 times 5 plus 12. This gives me 4, so I get 12. And this gives me negative 10 plus 12, which is 2. 12 equals 2. No, that is not a solution. Now I'm going to do the same thing, and I'm going to put in the 3. So 3 is going to go into both of them. 3 times 3 minus 1 equals negative 2 times 3 plus 12. 2, 6. Negative 6 plus 12, 6. Check. Yes, this is a solution. Two or more equations with the exact same solution are called equivalent equations. The properties that we're going to be discussing are the addition property of equalities, which states that if I add the same number to both sides, the equation stays the same. And the multiplicative property of equalities, it says that if I multiply the same number to both sides, it stays the same. Steps for solving a linear equation. Distribute, lose the fraction, combine like terms, bring variable to one side, and solve. Okay, so I am going to pick up my 2 and bring it over. Okay, 1x equals 6, so x equals 6. Step 2. Now the reason I use these 5 steps are you can use these steps in different orders, but if you use them in this order, they always work. And people seem to get confused in which order they should do things. For example, this one right here, you do not have to distribute. There are no fractions, but I do need to combine like terms. Then I need to bring the variable to one side. I like to bring my variable to the left because when we do inequalities, it's easier to graph when they're on the left. So 2x equals 10. Divide by 2, y is 5. This one I need to distribute. In fact, I need to distribute twice. 4x plus 12 minus 8x equals 3x plus 6 plus x. Fractions? No. Combine like terms. Negative 4x plus 12 equals 4x plus 6. I move my 4x over. I move my 12 over. Negative 8x is equal to 6 divided by negative 8. X is negative 3/4. I'm going to continue this on this side. Distribute, lose the fraction, combine like terms, bring variable to one side. There is nothing to distribute on the first one, but I can lose the fraction. The reason I can lose the fraction is there's an equal sign, and if there's an equal sign, that makes it an equation. When I have an equation, I can lose the fraction by multiplying by the the least common denominator out front. So what number does 4, 10, and 20 all go into? 20. So 4 goes into 25 times, 10 goes into 22 times, 20 goes into 21 times. So I'm going to multiply 5 times y plus 1 and get 5y plus 5. I'm going to take 2 times 2 minus 2 and get 2y minus 4. And I'm going to take 1 times y plus 7, and I'm going to get equals y plus 7. I'm going to combine like terms. 7y plus 1 is equal to y plus 7. I'm going to move my y over. I'm going to move my 1 over. 6y equals 6. Divide by 6, y is 1. Let's lose the fraction on the next one because there is no distributing, so I can go straight to losing the fraction. Common denominator of 9, 2, and 6 is 18. 9 goes into 18 2 times, 2 goes into 18 9 times, 6 goes into 18 3 times. Now I want to point something out. In the center of this is a subtraction sign, and I have to come in and change that to addition and change that to minus and change that to plus before I even begin, or I'm going to lose my sign. Then I'm going to do all that work and get the wrong answer at the end. 8x plus 6 is equal to negative 18x I'm sorry, not equals, minus 18x. Let's use that eraser and start again. 8x plus 6 minus 18x plus 9 equals 3. So I have negative 10x plus 15 equals 3. Subtract 15. Negative 10x equals negative 12. Divide by negative 10. X is 6/5. Now remember, we use improper fractions, not mixed numbers. For the next one, it looks like one of them doesn't have a denominator, but it does. I can put a 1 under it. Common denominator of 6, 1, and 3 is 6. 6 goes into 6 one time, 1 goes into 6 times, 3 goes into 6 2 times. So I get x plus 2 plus 12 equals 10 when I multiply it out. So x plus 14 equals 10. Subtract 14, x is negative 4. So that's how you lose a fraction. Okay, there are 3 types of linear equations. There's conditional, that's what we just did, where you get one answer. There are contradiction equations. They're equations that are always false because the variables drop out and you get things like 5 equals 9. Well, 5 never equals 9. It's no solution. The reason there's no solution are the 2 equations on the left and the right are parallel if I graph them. The identity equation is an equation that is true for all values on both sides. The variables will drop out and you'll get the same number on both sides. What that means is if I graph both sides, the left and the right, as equations, they would be the same line. So we're going to name what we get on these. So first thing we're going to do is solve them. 3x plus 9 minus 6x equals 5x plus 5 minus 8x. Combine our like terms because we have no fractions. Negative 3x plus 9 equals negative 3x plus 5. Move my 3x over, move my 9 over. I get 0 equals negative 4. Well, 0 never equals negative 4. Therefore, there is no solution because these are contradictions. Meaning that they're going to be parallel. Distribute. Negative 4x plus 8 plus 12x plus 6 equals 8x plus 14. 8x plus 14 equals 8x plus 14. I can see right now they're equal. But I'm going to move them over to show you what it looks like if you don't notice it. I'll get 0 equals 0. When does 0 equal 0? All the time, so it's all real numbers. So my answer will be all real numbers because these are identity equations. Meaning that if I graph both of them, they would be the same line. Okay, distribute here. So negative 4x plus 2 plus x plus 1 equals negative 4x minus 8 plus 11. Negative 3x, when I put these two together, plus 3 equals negative 4x plus 3. Bring my 4x over, bring my 3 over. I get x equals 0. Now some people are like, oh, this has to be one of the special ones because I got a 0. 0 can be an answer. X equals 0 is an answer, therefore it is a conditional. So these are conditional equations. So they're the 3 things that can occur. Okay, translating to algebraic sentences. Okay, I like to read the question and then go back and see what I have. 5 more than a number x is 20. So I have 5 more than x. That means x must come first because they're talking about it as if you're comparing to x. So x plus 5 is 20. 4 times the sum of a number z and 3 is 15. Well, here's a hint. Anytime you hear the words sum, which means addition, product, which means multiplication, difference, which means subtraction, or quotient, which means division, you should think parentheses. It means that most likely there's a set of parentheses opening. If the parentheses aren't opening at that point and you put them in, they won't hurt anything. But if you don't put them in, they will. So 4 times the sum, parentheses, of a number z and 3 is 15. The difference of x and 5 equals the quotient of x and 2. The difference, parentheses, of x and 5 is equal to the quotient, parentheses, of x divided by 2. In this case, the parentheses are not really needed. Therefore, having them there or not having there is not going to hurt anything. 3 less than a number y is 5 times y. Less than y means y is coming first. So y minus 3 is equal to 5y. Be careful that you read them, look them over, and then reread them and make sure they sound exactly how you want them to sound when you read them. Linear inequalities. Inequalities contain less than or equal to, greater than or equal to signs. You solve them like any other equation: distribute, lose the fraction, combine like terms, bring variable to one side, solve. Except if at any point you multiply or divide by a negative number, you must switch the direction of the inequality sign. Intervals. A is less than x, which is A is less than or equal to x, which is less than or equal to b. I have a less than or equal to, I have an equal to on both ends. That's called a closed interval. If I have an equal to on one end and not an equal to on the other end, it's called a half open or a half closed interval. And if I have not equal to's on both ends, they're called open intervals. An interval that contains infinity to negative infinity are just called intervals, and they're not considered open, closed, or half open or closed. And we have interval notation, which can be in the form of, instead of using the less than or equal to or greater than or equal to sign, you would use a bracket. And instead of using a less than sign or greater than sign, you would use a parenthesis. And I'll show you how that works in a second. Okay, so we're going to write into interval notation to function notation. Okay, so this has the equal to sign, so they're going to use the brackets. I started at -2 and I go to 4. That's how you write your function notation. This does not have an equal to sign, so it's a parenthesis. This has an equal to sign, so it's a bracket, so it's 1, 5. This does not have an equal to sign, but x is less than. So if x is less than, it goes to negative infinity to 2, not including 2. And infinity and negative infinity always have parentheses, not brackets, due to the fact that they're not included. X is greater than or equal to -3, which means we start at -3, including -3, and we go to infinity. I will expect you to be able to go back and forth with these. So here's a function notation. I wanted an interval notation. So it's -2. It's included, so it's less than or equal to x, which is less than 4 because it's not included. 1 is less than x, which is less than 5, not included. X is greater than and equal to 3/2. X is less than, but not equal to, 1. That's how you move them back and forth. Okay, solving inequalities. To solve inequalities, we're going to do the exact same thing. We're going to distribute, lose the fraction, combine like terms, bring variable to one side, and solve. So I'm going to pick up the 3 and move it over. I'm going to get 4x is less than 16. I'm going to divide by 4. X is less than 4. So if I need to graph this on a number line, I would go to 4, put an open dot because it's not equal to, and point to the left. I could also graph it with a parentheses pointing it to the left. On this one, I'm going to lose the fraction by 3. 3 goes into 3 one time. 1 goes into 3 3 times. 1 times 1x is x. Is less than or equal to 6. It's already solved. 6, solid dot pointing to the left, or bracket pointing to the left. You don't have to do both of them, just pick one. Distribute. 3x minus 3 plus 2x is less than 6x plus 3. Combine, no fractions, so combine like terms. 5x minus 3 is less than 6x plus 3. Move my 6x over. Move my 3 over. Negative 1x is less than 6. Divide by negative 1. Now remember the rule. If you divide by a negative number, the sign will switch directions. So instead of being less than, it'll be greater than negative 6. So open dot at negative 6 pointing to the right, or a parenthesis pointing to the right. Distribute. 7 minus 2x minus 2 is less than or equal to 3x minus 15. 5 minus 2x is less than or equal to 3x minus 15. Move my 3x, move my 5. Now I always move my variables to the left because it's easier to graph when they're on the left, even if I have to switch the sign. Because if the x is on the left, you can graph according to which way the arrow is pointing. So x, flip the sign, is greater than or equal to 4. So I go to 4, solid dot, and see the arrows pointing to the right, so I graph to the right, or bracket to the right. Distribute. Negative 2x minus 2 is greater than or equal to 4x plus 12. Move my 4x, move my 2. Negative 6x is greater than or equal to 14. Divide by negative 6. The sign will switch directions. I'll get 7/3, negative 7/3. 7/3, negative, solid, to the left, the arrow is pointing to the left, or bracket to the left. Distribute, no. Lose the fraction, yes. 3 and 2 both go into 6. So 3 goes into 6 2 times, so this will get multiplied by 2, and 2 goes into 6 3 times. So 2 times 2x plus 1 is 4x plus 2, and 3 times x minus 2 is 3x minus 6. Move my 3x over, move my 2 over. X is greater than negative 8. Negative 8, open dot to the right, parentheses to the right. Much easier to graph if my x is on the left. I'm going to put a 1 underneath my 2, and 5 and 1 reduced by 5. So 5 goes into 5 one time, and 1 goes into 5 5 times. So 3x plus 1 is greater than or equal to 10. Subtract 1. 3x is greater than or equal to 9. Divide by 3. X is greater than or equal to 3. 3. Solid dot pointing to the right, or bracket pointing to the right. Common denominator between 5, 10, and 2 is 10. 5 goes into 10 2 times. 10 goes into 10 1 time. 2 goes into 10 5 times. So 4x plus 3 is less than 5. Move my 3 over. 4x is less than 2. Divide by 4. X is less than a half. Open dotted at half pointing to the left, or parenthesis pointing to the left. Compound inequalities. Compound inequalities combine two inequalities with the word and or. An intersection, which is written as a with an upside down U, B means the common elements in both sets. It means an and. It means where they overlap. A union is written as A, U, B. Means that all the elements in both sets are part of the answer. And it's an or. Means that it's not the overlaption, but everything. So let me give you an example here. This, I only want the intersection because it's an and. So they have to be in both sets. 7 is not in both sets, but 8 is. 9 is not in both sets, but 10 is. 11 is not in both sets, so there's my and. In the next one, it's an or, so I don't care if they're both in both sets. I just want them in one of the sets, at least. So 7 is in one set, 8 is in both sets, 9 is in one set, 10 is in both sets, 11 is in one set, 12 is in one set. So that is my or. So the difference is, and is looking for the overlapping. It usually looks like it's between two. Or is looking for anything in either of them. They usually are facing apart from each other. Okay, next page. Okay, so I'm going to do some ands and ors. The first up here, say and. This does not say and, but it is an and because it's in between. So, with the ands, you just solve them as normal. Subtract my 4, divide by my 2, and I get this. Now, I always graph them because an and is supposed to be colored in between. I have an 8 going this way and a 5 going this way. Where's the overlapping at? Because an and is an overlap. Well, the overlapping starts here. So this is not part of the solution. That's the only solution because I'm looking for the overlap. Add 7. Divide by 2. Add 4. Divide by 5. I'm a visual person, so I like to graph them to see what it looks like. Okay, I'm looking for the overlapping. And is overlapping. There is no overlapping, so guess what? There's no solution to this one. Okay, now this one you can separate it into 2 separate problems if you'd like that, and solve them. And that's not a problem, that's fine. Or you can solve them while they're in the form they're in by looking at the middle and saying, oh, the 1 needs to move, so I'll move the 1 from all the sides. Ah, look at the middle, the 2 needs to move, so I'll divide all the sides by 2. So, I get 1 with a solid dot, negative 2 with an open dot, and x is in between, so it's colored in between. It looks like an and. That's the overlap. I'm going to lose the fraction first. 1 goes into 2 2 times. 2 goes into 2 1 time. 1 goes into 2 2 times. So 2 is less than or equal to 2x plus 3, which is less than 22. Look at the center. First thing I'm going to move is the 3. I'm going to subtract 3 from all sides. Negative 1 is less than or equal to 2x, which is less than 19. Then I need to divide by the 2 to get the x by itself. I get negative 1/2 is less than or equal to x, which is less than 19/2. Negative 1/2 gets a solid dot. 19/2 get an open dot, and I color in between, so that is an and. Now, an or. Solve them the same way, but they will always say or in between them. They will never be like this where you have to guess if it's an and or an or. An or will always say or in between them. So 2x is less than 10. X is less than 5. Subtract my 35. Negative 4x is less than or equal to negative 32. Divide by negative 4. X is greater than or equal to, because I had to flip the sign, 8. So let's see. 8 solid dot greater than. 5 open dot less than. That's what an or is supposed to look like. So this is my answer. If I need to write this in function notation, go back to your graph. It's going to negative infinity, so it's negative infinity up to 5, but not included. Union starts at 8, it is included, and the arrow goes to infinity. Move my 5. 3x is less than or equal to 18. X is less than or equal to 6. Move my 2. 5x is greater than negative 5. Divide by 5. X is greater than negative 1. 6, solid dot this way. Negative 1, open dot this way. It doesn't look like an or, it looks like an and. When an or looks like an and, it means all real numbers. So if an and looks like an or, it's no solution. If an or looks like an and, it's all real numbers. Okay, equations and inequalities involving absolute value. Absolute value looks like this, a v. So there's normally 2 answers on an absolute value, one on the left and one on the right. Therefore, when you take the absolute value sign off, you will make whatever's inside the absolute value equal to the positive number, and then you'll have it equal to the negative number. We will then get the boundary points that are on the absolute value that cross at x. We can take test values and we can shade in there if we need to, and we can talk about our margin of error, and I'll talk about that in a second. Steps to solve an equation with an absolute value. Get the absolute value by itself on a side. Write the equation twice. Take off the absolute value signs and set it equal to the positive value of the right side and the negative value on the left side. Solve both. These are your boundary points. So here are some examples. The absolute value is already by itself, so I split it in half. I write 2x minus 3 equals 11, and 2x minus 3 equals negative 11. I move the 3, and I divide by 2, and x is 7. I move the 3, I divide by 2, and x is negative 4. These are my two boundary points, meaning that if I graphed at negative 4, I'd have a dot on the x-axis, and 1, 2, 3, 4, 5, 6, 7, and a 7 I have a dot on the axis. And my v would probably go like that. Now remember, I just estimated my v. That wasn't an exact. Okay, on the next one, I have to have the absolute value by itself. It's not, so I have to move the 15 over. Then I have to divide by 5. Now that the absolute value is by itself, now I can split it into two. Positive and negative version. Move my 1 and divide by negative 4. Move my 1, divide by negative 4. My boundary points. Now what happens if you have an absolute value on both sides and they're by themselves? Well, you keep the absolute value on the right, and then you keep the absolute value, on the left and the right for the first one. And the second one, you keep the one on the left, but you make the right its opposite. Just like when I made 3, it's opposite to negative 3. Then I solve, and x equals 3. And I solve, and x equals negative 1. My boundary points. Now, if you have an absolute value, let's say you have 3x minus 2 is equal to negative 4. The absolute value is by itself, but you might as well stop right now, because an absolute value, once it's by itself, is never equal to a negative number. Therefore, there is no solution to this. So if you see an absolute value that's equal to a negative number, there is no solution. Because remember, all absolute values are positive. Steps to solve an inequality with absolute values. It's the same thing. I'm going to get the absolute value by itself. I'm going to take the absolute value off and do two separate ones. One will be the absolute value and the sign and the positive number. And then I'm going to do the absolute value, the opposite sign. So if it was less than, it's now greater than. And the opposite value, if it was positive, it's negative. So let me show you how we do this. Okay, the absolute value is by itself, so I split it into two. X minus 4 is less than 3. X minus 4 is greater than negative 3. The sign switches. I always hear from students, why didn't you switch the equal sign? How do you know I didn't? If you switch the equal sign, you still have an equal sign. Solve, x is less than 7. Solve, x is greater than 1. So in this case, my boundary points are 7, 1, 2, 3, 4, 5, 6, 7, and 1, and I'm going to color in between, so when I do my absolute value is going to be colored in between. Absolute value by itself, so 2x plus 3 is greater than or equal to 5, and 2x plus 3 is less than or equal to negative 5. Move my 3, divide by my 2, move my 3, divide by my 2. So in this case, 1 will be a solid dot, and a color this way, And -4 will be a solid dot, and it'll color this way. So if I had an absolute value, I'd be coloring on the outside of my absolute value. Okay, do not distribute in. You need to move everything away from the absolute value before you can begin. Now I see a negative on the absolute value, but it's not by itself yet, so don't assume there's no answer. So the absolute value of 3x plus 5, switch the sign because I divided by a negative number, is less than or equal to 10. Now I split them. 3x plus 5 is less than or equal to 10, and 3x plus 5 is greater than or equal to negative 10. Move my 5. 3x is less than or equal to 5. Divide by 3. X is less than or equal to 5/3. Move my 5. 3x is greater than or equal to negative 15. Divide by 3. X is greater than or equal to negative 5. So here are my two values. Okay, analyzing an error or understanding an absolute value, what it says, and writing one. Okay, an absolute value is x minus the median. Median is the middle value. Then it's less than or equal to the error, the amount you can go up or down. So what this means is my middle value is 9, and I'm allowed to go up or down 2.9. So I want to write one for if my middle value is 11, and I'm allowed to go up 1.2. Up or down 1.2. Now, when would you use this? Let's say you were putting in a handrail, and the handrail had to be 36 inches off the ground as a median, and you were allowed a 2-inch up or down variation. Well, if I was writing that, my median would be 36 inches, and I was allowed to go up or down 2 inches, which means I could go to 38 inches or down to 34. Watch when I solve this, what happens. Add my 36. I get x has to be less than or equal to 38. Move my 36. X has to be greater than or equal to 34. So there are my 2-inch variations. Now, you have done equations and inequalities. Now it's your turn to practice.